Hi math friends, today we're going to be working with solving systems of equations by substitution. What is substitution? We've seen substitution before when we plug in or replace a variable with a number or with something else, with another value. So today we're looking at a system, so we have two equations here, and we're going to see how can I just substitute to solve this. So each of these equations is solved for y. So what I'm going to choose to do is use the second equation, y equals 5x plus 3, and I'm going to substitute 5x plus 3 in for y in the first equation. Okay, so we have 5x plus 3 equals 2x minus 3. And the reason I can do that is y equals that, and y is right here, so I can just substitute that right in. And then we need to solve this, so I need to move my x's to one side. I'll have 3x plus 3 equals negative 3. And then I need to isolate that x, so I'll get rid of that plus 3, so subtract 3. And then I have 3x equals negative 6. Remember, inverse of multiplying, we divide. And I have x equals negative 2. Now you might ask yourself, x equals negative 2, there we go, I'm done. Well, wait a minute. Remember, a solution to a system is an ordered pair. It should be a point on a graph. X equals negative 2 is not a point by itself. So let's take that x equals negative 2 and substitute it into one of our original equations. I'll choose the first one. So y equals 2 times negative 2 minus 3. And then let's simplify. Y equals 2 times negative 2 is negative 4 minus 3. And then we'll simplify that again. Y equals negative 7. Okay. So you might say, well, my solution is negative 2, negative 7. I'm done. Well, let's check that first. Negative 2, let's check that in our second equation. 5 times negative 2 would be negative 10. Negative 10 plus 3 would be negative 7. So we see that we have negative 2 and negative 7 there. So that works out. So I'm going to write my solution. Negative 2, comma, negative 7. We're going to see some situations where x or y is not already isolated. So before we had y equals and y equals. Now we have 4x plus y equals 17 and y plus x equals 2. I don't have a variable just by itself. Neither of these equations is already solved for a variable. What I'm going to do then is I'm going to choose the second equation and I'll solve it for y. So I'll subtract x from both sides, and I'll have y equals 2 minus x. Since y is all by itself, now I can substitute in 2 minus x for y in my first equation. Okay. I want to make sure to use parentheses because if this y has a coefficient here, I would have to distribute that coefficient here. So let's go ahead and, there's nothing to distribute now, so I'll just remove parentheses. Okay, and then we'll combine like terms and start to solve this. So 4x and minus x is 3x, plus 2 is 17, and then we'll solve for x here. And then last step, divide by 3. And I get x equals 5. And remember, that's not your solution yet. We need an ordered pair. Let's use 5 back into one of our equations. I'm going to use it in this equation. So y plus 5 is 2. And we'll subtract 5 from both sides. And I get y equals negative 3. So we see that our ordered pair should be 5, negative 3. Let's use that in the other equation though, just to make sure that it works. 4 times 5 would be 20. 20 plus negative 3 would be 17. So our solution is 5, negative 3. Remember to write that as an ordered pair.